to protect your soul. I live inside my own world of make-believe. Kids screaming in the cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything.
Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. Just in case you're for the first time over here, welcome to the channel. And if you don't know me, I go by the name Striver in the programming community. If you want to check me out, you can definitely check me out on LinkedIn. I'll be leaving my link LinkedIn, Twitter, Instagram, Telegram, all the social media handles in the description below. So without wasting any time, let's get started. So Take You Forward is a full-fledged interview preparation website that I run on my end. So if you're someone stats of DSC2, imagine you open all the success Instagram of the Strivers SD. Today we will be C++ and I'll be covering all these basic stuffs related to C.
यार आप लोग भी जी सकते हो मतलब पढ़ाई तो करना है बिकॉज वेब डेवलपमेंट एंड स्ट्रिंग्स आपको मिल जाए सर्विस गूगल के इंजीनियर से ही कंटेंट ये लोग बनाया है तो कंटेंट इज टॉप नॉच द सर्विस इज टॉप नॉच अगर आपको एक्स्ट्रा डिस्काउंट चाहिए देयर इज अ लिंक
in the longer run. So the first thing in order to write a C++ code is the skeleton of C++ code. Now the strings. Now arrays will be covered in depth. Over here we will be covering 41 problems and strings will be covered on the upcoming lectures. But as of now, we just need to know the basics of arrays and strings. So let's start with arrays and strings. So when do we use arrays is a very big question. When you have a similar data type being stored multiple times. For an example, over here I'm giving you 4 datas. So you can see that these are integer data types, right? 3, 4, 5, 7. These are
Content, hold your breath and feel the tension. Devils hide behind redemption. Honesty is a one-way gate to hell. I wanna taste consumption. Breathe faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out. Just wanna be carefree, let
the integers. So one of the ways you can store them is, by the way, template, yeah. One of the ways you can store them is A, B, C, D. And you can say scene of A will take 3. Then you can say B will take 4, C will take 5, and then D. So apparently all these 4 integers, one by one, will go into these 4 variables. But imagine if you have 50 data. You can't have 50 variable names, because to name 50 variables, it's gonna take a lot of effort. That is where something like an array is used. So what I say is, I know the entire data is of similar type, which is integer. Why can't I define an array? So what I do is, I say int array of, let's for an example, say 5 numbers are there. Int array of 5. So what this does is, I'll give you a diagrammatic representation. This creates an array of size 5. Now this size 5 array looks something like boxes. Every box can store an integer. The 0th index can store an integer. The first index can store an integer. The second index can store an integer. And all the indexes can store an integer. What is an index? This first guy is referenced by 0th index. The second guy is referenced by first index, one less. So if the size is 5, the last index will be 4. So this is how an array will look. And depending on the data type that you have given, every box or every location of that array or the index is gonna store an integer. If you would have defined it as, let's say, long, it would have stored long in that index. If you would have defined it as character, it would should have stored character in that index. So over here, our use case is defining it as an integer. So I will define it as an integer. Now I'll say cin of array of 0, cin of array of 1, cin of, oh my bad, I'm taking the other one, array of 2, then I'm say array of 3, then I say array of 4. So what happens is the 0th index takes 3 and everything is stored. Now imagine I want to print 7. I want to print 7. So what you can say is cout of array of, where is 7 stored? 7 will be stored at the 0th index, first index, second index, third index, second is 3. Yes, and if you print this, let's see if 7 was stored. You saw? So what happened was these 5 numbers went in and were stored in these places consecutively. So when you access the third index, it means the fourth element got accessed and you got the fourth element. Can you modify these? Yes, you can. If you want to do operations on them, you can. Imagine I say array of 3. Can you go ahead and add yourself 10? So if it adds 10 to itself, 7 should become 70. Let's see if it becomes. It does. So you can modify. So it is exactly as a data type. You like whatever you wish to do, you can do it. If you want to do something like, hey, array of 3, replace yourself with 16, change your value to 16. It can as well. You can do whatever you wish to with this particular array. You can treat it similarly to an integer data type. Got it? So this is how you can store similar data like together. And the container used is array. There are multiple other containers as well. I have talked about that in the C++ STL video. You can definitely check it out as well. So we got to know what is an array. And the most important thing is everything has to be of a similar data type. You can't be 7. If you say 7.7, what will happen is, since you declared this to be an integer data type, this 7.7 will trim itself to an integer and hence it will be stored as 7. Got it? If there is a double data type, maybe you can store double. And if you say double, then 7.7 is stored. Whatever data type you give, that has to be constant for all the elements. That is the key point. Okay. So that was about the array. Now, where is the array stored? We know it is 0th index, first index, but the entire thing is taken and stored in a memory location. Yes, the entire thing is taken and stored in a memory location. So this guy, 0th index, is stored at a particular memory. And that memory can be of any address. That address is very randomized. I cannot say that it is stored in, let's say, India. Like, there is nothing like at this memory address it is stored throughout the CPU. Now, the first index. Now, that one I can definitely say will be stored right after the 0th guy, right after the 0th guy's memory address, right? The consecutive one. Then the second guy will be stored right after that. So the 0th guy, we're not sure, but we are sure about the next guys because they will always be in consecutive. So remember, array elements are stored in consecutive memory address, but I'm not sure where the first one will be. It can be at any randomized location. Very, very important point to remember. But will it be required in DS algo? I don't think so. But it is a point which is important and you should keep in your mind. So till now, we did learn about the 1D array. Now we will be learning about the 2D array. What is a 2D array? Again, I'll be giving you very basic idea about 2D array over here. Eventually, when we move across the playlist, we will be learning about 2D array in depth. If this was declared, this was something like 5 guys or 5 boxes indexing from 0, 1, 2, 3, 4. Correct? Now, the moment I say I need 5 boxes, but I need them 3 times, I'll add 3. What it means is I'll have 3 5 boxes. If I show you diagrammatically, this is what I'll have. 3, 1, 2, 3, 5 boxes. 1, 1, 2, 3, 4, 3, 5 boxes is what I'll have. So this is what it means. This is the row number. We generally call this as row and this as column. And if I talk about the indexing over here, again the indexing starts from 0. And this is how the indexing goes. You see 0, 1, 2, and this is 0. So this guy is known as 0, 0. This guy is known as 0, 1. This guy is known as 0, 2. This guy is known as 0, 3. So this is how the naming or the row and column goes. If I say 1, 3, so here is 1 and here is 3. 76. The value will be 76. If I say give me the value at 1, 3, the value will be 76. Again, if you want, give me the value at 1, 3, the value will be 76. Again, if you want to assign, like it'll be like A1, 3 equal to, you can say 78. And then you can go ahead and say C out of A1, 3. We will be seeing the use of 2D matrix a lot. We'll be solving a bunch of problems. Don't worry about that. So this will be array and this will be array. So if you go ahead and print this, you'll be seeing that we're actually getting 78 at this location. And for the locations that you have not defined, they'll be assigning themselves some garbage value. It can be any value. Like if you try to print 1, 2, you'll see it is having a garbage value. Like if you try to print it again, it will have different values. Every time you print, it has some garbage value that comes in from the system because you did not initialize. The only guy that you initialized one was the first row and the third column in terms of 0 based indexing.
Hello, 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 mic test. Hello, morning.
Very important. In arrays, we have zero-based indexing. Okay. When is 2D array used? It is used to solve a lot of matrix problems, a lot of graph problems, which you'll be dealing with in the future. Okay. As of now, just know this is what we know as 2D array. This is the row, this is the column, and it goes as row and column. That's it. That is what you have to keep in your head as of now. So in the STL video, I've talked about a lot of functions related to arrays, vectors, list, and a lot of other things. So you can definitely check that video after this one. So we have known about arrays in basics. Now let's talk about string. So imagine this is the string that I am having. String s equal to string. And now I want to access I. So the string also stores every character in terms of indexes. So s will be at the 0th index. So if you try to print something like c out of s of 0, what will happen? See, s will be printed. If you say s of 1, see what happens. T will be printed. If you say s of 2, you know what will be printed. R. So every character is stored at an index. And the first index is the 0th index. And what will be the last index? Whatever is the length. So can I say the length is, this is how you find the length. Length equal to s dot size, or there is another function as length which you can use. So if I say length minus 1, Because I know last index, because everything works in zero-based indexing. The last index will be n minus 1. I know it. If I print this, what will be printed? Driver R, because this is what happens at the last index. That's how you can easily access the string. If you want to change any value, imagine you want to say, hey, I'm not interested in this. Please make it Z. Strives. And I do it. It gets changed to Z. So you can also change it. Remember,
just a little bit from grace. Darling, we're gonna make a mess out of this place. We own the night, it's when we come alive. Till morning light, when we go back to hide. It's time to ride, we're going wild tonight. When you hear the clock strike. You hear the clock strike 12. When you hear the clock strike. Moonrise, signaling that it's our time. Owl cries, the whole kind. Red eyes, don't you worry, it's alright. New highs, we haven't reached, just being wise. We own the night, it's when we come alive. Till morning light, when we go back to hide. It's time to ride, we're going wild tonight. When you hear the clock strike 12.
these are characters. Characters at every index. And characters, when gets added, makes up a string. So all of these are characters. You can't do something like this and expect this to work. If you do this, it will not work and it will give you errors. You see, errors. So since it is a character, you have to assign it with a character. So string is storing characters within itself. So if you know about this and the length function, eventually we will be solving a lot of string problems, and there you can easily get on with strings. So we are done with arrays and strings. Now it's time to do for loops and while loops. And as of now, I'll be talking about basics. Eventually, we'll be solving a bunch of patterns. And once you end up solving all these patterns using for loops, trust me, your logical thinking, your concept of for loops will be super strong. And then we'll move on to solving maths and everything using the for loops and while loops. And eventually, in the entire DSA, for loops, if you don't know for loops, you can't do anything. So please stay focused. So what is for loops? Why is it used? Imagine I say you, hey, print your name. So I'll be like, see out. Okay, what's mine? My name is Trevor. And I'll print it 5 times. Done. 5 times sprint. Sprint 500 times. 500! That's a lot. This is where for loop comes. For loop says, same line of code. Why do you want to write it again and again? I'll do it for you. So what for loop says is, hey, same line of code, right? Write it once. And then enclose it inside me. Inside me enclose it. And the for loop says, okay, my syntax is very simple. Say for, what is the variable that you want to go across? How many times you want to run? Put up a variable for that. I want to run it for 5 times or 500 times. What is the initial? First, I equal to 1. Variable declaration, I equal to 1. Variable declaration. This only gets executed for the first iteration. Only gets executed for the first iteration. Then, condition at which I'll stop. The for loop will stop. The looping will stop. So I'll be like, the condition is 10. I'm saying, till I don't reach 10, I'll not stop. And at every step, I have to do something. If I don't do, I will forever stay 1. And if I stays forever 1, this condition will always be true. And if it is always true, that line of code will run. And it'll never end. This is where something like increment or decrement, your wish, comes in. And I say, this is the line that I use. I want to execute. And I go ahead and write this line. Now what happens is, see what will happen. I'll tell you how it happens. Wow. 10 times. Exactly 10 times driver got printed. What happened was, first initialization. I equal to 1. First time, I is 1. I lesser than 10. Yes. Goes. Prints. Printed. Comes back to this line. I gets 2. Next. Goes here. 2 lesser than equal to 10. Yes. Goes. Goes here. Prints. Goes again here. I equal to 3. After here, goes here. 3 lesser than equal to 10. Yes. Prints. Then goes here. I equal to 4. Imagine this is 5 for an example so that I can explain. I equal to 4. Prints. Goes again here. I becomes 5. Prints. Goes here. I becomes 5. Checks. Prints. Goes again here. I become 6. The moment I become 6. 6 lesser than equal to 5. No. Stop. So it will get executed 5 times. But if you try to print the value of I, imagine you want to print the value of I, something very important to notice. If you print it like this, it will not be able to find I. Why? Because the scope of the I was declared inside this. So the scope, wherever you declare I, the scope is limited to that. So the other way you can do is, you can say I, and you can write something like this. So you declared the I here, and then you've initialized it here. So if you print I over here, see what happens. So if I print I, the last value of I is 6, where it got truncated. You can run the for loop in the reverse order as well. Something like, hey, maybe start from 5, maybe go on till, and maybe decrease it. So if you do this, and if you print the value of I, you can see the value of I. Oh, sorry, my bad. If you want to print the value of I, maybe go like this. Oh, sorry, maybe like this, and yeah, just you go. See the value of I. 5, for the first, and 4, then 3, then 2, then 1, and 0. Got it? So you can write the for loop as you wish to. Is it mandatory that you reduce by 2? No. I want to run this for 5 times. How I run it for 5 times is my choice. I can be like 1. I can be like, I need for 5 times. I will go to 5 times. So you can write the for loop as you wish to. Is it mandatory? That you reduce by 2? No. I want to run this for 5 times. How I run it for 5 times is my choice. I can be like 1. I can be like, I need for 5 times. I will go till 25. I will do I into, or maybe I plus 5. My choice. I can go like 1, 6, 11, 16, 21. My choice. That's my choice. No one is here to stay. How I run doesn't matter. How many times I run is what matters. This condition depends on you. What you need to make sure is, if you want it for 5, if you want it for 10, if you want it for 20, make sure the condition is written in such a way that it runs for that many number of times. That is the core concept of for loops. Do we have nested for loops similar to if? Yes, we do have. And the nested for loops is something which I'll be teaching you while printing patterns. As of now, this is what you need to know. Can we write if conditions inside the for loop? Yes, you can go ahead and write if. Any line of code can be written inside any for or any while loop. So this is how you write a for loop. Now, I want to convert this exact similar for loop. I'll just comment it out. I want to convert this exact similar for loop into a while loop. So the while loop does the same thing. The task is same. Whenever I attach something like loop, the task remains same, executing some lines of code for some number of times. We do the same thing. And here, the only difference is the syntax changes. While executes like this, whatever is the condition will go here. And whatever is the increment goes at the end, goes at the last line. Whatever is the increment goes at the last line. Okay? And the initialization goes over here. First time initialization happens. While says 1 is less than or equal to 5, fine. Go ahead and do C out of Trevor. And if you want to print i's value, you can also check it out. If I go ahead and do endl, you'll see the value. See, perfect. So what happens? Check, print, increase, check, print, increase. First check goes inside, increases, comes back, checks, prints, increases. Very simple. This is how a while loop executes. So this is about while loop. Now while has one more concept, and that concept is do while loop. Okay. Now what does do while mean? So can I say if I keep I equal to 2 and I keep something like this, will it execute? The answer to that is no. Because I is 2, the condition is false, never executes, goes to this, ends the program. So do while says, you don't know the condition because when you're writing code in industry or maybe you're solving a problem, you might have such use cases. So you always want one thing to happen, that is, you want your line of code to be executed minimum for one time. Minimum for one time. That is when you say, okay, if I want it to be executed for minimum of one time, I will write it something like do, and I'll put this at the end. And then I'll be doing the same thing. So what will happen is, even if the INDI is defined as 2 and the condition doesn't execute because it doesn't allows me, and then you end it with a semicolon. Even if the condition doesn't allows me, do says, do it for the first. Go ahead, do it for the first. Then increment, then check, then do. So if you say I equal to 2, see what driver 2 gets printed. And then if you see the value of I at the end of the while loop, let's print. What will happen? The value of I was 2. You printed driver. I increased to 3. And 3 was less than equal to 1. And it got ended. But do will make sure the first time it gets executed, irrespective of what condition you are giving. So this is the basic, like you can define it here, you can define it before this, that is your choice. But this is the basic of for and while loops. So I can say this is the basic of for and while loops. Eventually, when we solve these amazing set of patterns, the concept of the for and while loops will get more and more into your head, and you'll be very strong in logical thinking. And eventually you can apply for loops in maths, recursion, and all the other problems. Okay, what's the next thing? Functions, pass by reference and pass by value. Functions is very, very important because we'll be using functions throughout. Yes, throughout. To solve any problems, we will be writing functions. So please make sure you understand functions in a proper depth. So let's start with functions. What are functions? Functions are a set of code which performs something for you. Now, if I want someone to do something for me, like for an example, if I want to order food, I can say I can deliver food from a food delivery app, and that will bring me in food. So you can say functions are similar. You want it to do something, you'll give it or maybe something, and it will do that for you. That is the role of a function. Why are functions used? Functions are used to modularize code. Now, a lot of times you'll be having hundreds and hundreds of lines of code, and it becomes very clumsy. So in order to modularize, because every portion of the code will be doing something, so that something will be put into a function. Okay, functions are used to increase readability. Now imagine you are writing code and you have like 1,000 lines of code. You know what every line is doing. But if someone from outside is reading your code, he might not understand. So what you do is every step you put it into a function. Name the function in such a way that it is understandable what it is doing. Got it? And functions I used to use the same code multiple times. So if you are performing same, like if you're using the same set of code again and again, it's not good to write the same code again and again. So you can put them into functions and use the function. Okay, so I'll be showing you all these things. So there are basically there are a lot of kind of functions, but usually we do use like 4 kind of functions. One is the void function, the other one is the return function, the other one is where we carry a lot of parameters, the other one is where we do not carry any parameter. Okay, so non-parameterized functions. So let's talk about the first one, void function. The void function is something which does not returns anything. Very important, it doesn't returns anything. So imagine I'm saying print your name. You know that is easy. You'll come across and say, hey, see out, hey Striver, printed. So you know one thing, if I'm saying hey Striver, that is something which I know. But if someone is coming from outside and is reading this, like, what does see out mean? I don't know what see out means. This is where readability comes in. If I do not know C++, I will not be knowing what see out means. That is where we say, okay, let me write a function. So what function I'll write is, I'll say, okay, void. That is the keyword. It means it will do something, but it will not give me some. It will not give me some. And then I'll write the function name. I have to print the names. So I'll just write print name. And in that, I'll put this. So it did not return me anything. It's a void. It will never return you anything. And this is the function name. And this is a non-parameter. It will not carry any parameter. Whenever you enclose it within parentheses and there is nothing inside it, it doesn't carries a parameter. So it does this. Now over here, if you just run this, this will not be executing this function because this is outside the main. You know the skeleton of the code is executing anything that is inside the int main and the function is outside. So what you do is you say print name and you execute this. Now what will happen is int main will come, print name will happen, and then it will go across and execute the line of code. See, hey Striver, executed. Now imagine I say take a input and print the name. So you'll be like, okay, this is the line. Maybe I'll take int name and I'll say scene name. And I want to print this name. I want to say, hey, this name. And this name might be Raj. So if I say just print name, what will happen? See, it'll still print hey Striver. I want you to print hey Raj. This is where something like a parameterized void function comes in. I know I have to take this name. Maybe I'll pass this name. So I'm saying print name, take this name. Print name will say, okay, please give me this. What? Oh, by the way, string. What is the data type of this thing? It says string. I'm passing the name, but it gives you red. Why? Because this guy is not taking any parameters, but I'm giving it name. I'll say, okay, what are you giving me? You're giving me a string. I'll take the string. I'll take the string. When I've taken the string, now I'll say, hey, can I say name? See what will happen. This function took this name and print. Now this moment when you say Raj, see what happens. Hey Raj. If you say Straver, it will say hey Straver. If you say Aman, it will say hey Aman. Simple. This function, what is the function of this function? Takes a name and prints a name. Very simple. It can take any name. So you can maybe use it again. See string, name2. And you can maybe take name2 and you can say print name. See reusability of codes. I'm using the code again and again. And I can say, okay, Aman and then Raj. And then maybe over here, let's give an endl so that every time it says hey, you like see what happens. Hey Aman, hey Raj. Now, had you written in this line, you'd have written it again and again and again. But this is where reusability of code comes in. Now, this is not under, like, you can maybe put it under for loop, that is okay. But if there will be cases where you cannot use for loops, but you have to use shuttle lines of code again at different places. That is where something like a function comes in. So I can call this as a void function and as well as a parameterized function. So you have understood non-parameterized. Okay, now the next question. That we will do is take two numbers.